welcome back, and this video is going to be all about the binomial theorem, which might sound a bit daunting to you because what is binomial and wow, a theorem sounds complicated, but don't you worry because I will explain it to you, and it's actually really simple and very straightforward once you get the hang of it. So let's start off with what is the binomial theorem. Well, to do this, I'd like to go back to something that we are all familiar with, probably sick of seeing maybe, but x plus y squared. So how would you factorize this, or how would you expand this more like? So maybe you write it out, maybe you just know in your head, but we all arrive to the same conclusion that this is going to be x squared plus 2xy plus y squared. Now what about x plus y cubed? How would you do this? Well, you might take our previous expression and simply multiply that by x plus y. Might take a little bit more time, still doable. Now what if I asked you what x plus y to the power of 17 was? That is quite complicated to work out. Doing this method will take forever, and you definitely can't just do it in your head. So how will we do it? Well, this is exactly what the binomial theorem helps us with, otherwise I wouldn't be mentioning it. So if you've ever seen the binomial theorem, you probably come across something that looks something like this. I must point out that this notation right here, which is the combination notation, is also sometimes expressed like this right here. And so what this whole expression here means is that if we have two variables, a plus b to the power of n, the way that we expand them follows this pattern or this rule right here. So first we're going to have a to the power of n, which is also, we can write in front the combination of n and 0, but this cancels out as we'll see in a second, so we just write a to the power of n. Then we're going to have the combination with n and 1, and then we decrease the power of a and increase the power of b. Notice, as we go on, we decrease a but increase b, and the sum of them is always going to be n, because this is b to the power of 1. Keep that in mind. So this leads us to our generalized version, where we have the combination of n and r is the exponent of b, and n minus r is the exponent of a. And we do this all the way until we get to b to the power of n right here. And the exponents themselves are calculated with factorials, and if you need just a quick reminder, a factorial is basically just the number multiplied by all of the consecutive numbers that come before it up until 1. So for example, 3 times 2 times 1 is 3 factorial. So let's do a very simple example. Let's do x plus y to the power of 3. So if we expand this, we get the combination of n and 0. I will write it down just to show you why it's 1, multiplied by x cubed y to the power of 0. So I'll write this out as well, but we often skip this step. And then you have the combination of n and 1. And in this case, n is 3, so we can just write 3 and 1 times x squared y to the power of 1. We decrease x, we increase y, plus the combination of 3 and 2 with x times y squared. And then lastly, we have the combination 3, x to the power of 0, y cubed. So let's start off by figuring out what these combinations, or we can write them as this, are. So this right here would be n factorial over 0 factorial, and n minus 0 just n factorial, which cancels out to 1. This is exactly why we don't write this. This is always going to be 1. So we can right away write is equal to x cubed, because y to the power of 0 is just 1. Then let's figure out what this right here is. Well, this is 3 factorial over 1 factorial over 2 over 3 minus 1, which is 2 factorial. And we can write this down as 3 times 2 over 2 factorial, because 1 factorial is just 1. And this is going to equal to 3. So our coefficient here is going to be 3 x squared y. Now over here, this is going to be 3 factorial. Once again, now 2 factorial, 1 factorial, which is the same thing as over here. So we can write this as 3 times 2 factorial over 2 factorial, 1 factorial, cancel this out, and we get 3. So we're going to have plus 3 x y squared. And then last but not least, this is the same case as for the other, where we have 3 factorial over 3 factorial over 0 factorial, which is going to give us 1. So we just have y cubed. And this is the full expansion right here. So practice some more. You can just say x plus y to the power of 4 to the power of 10 and just do these expansions until you really get the hang of it, because the faster you go, the easier it's going to be and the more intuitive it will become. So let's look at a bit more complex example. So this example goes as follows. We want to find the term with x to the power of 4 in this expansion right here. And at first this might seem a little bit daunting, like what? How do we do this? But if you go back here, you should realize that even though we're adding our variables over here, in the actual expansion, they're being multiplied. So what this tells us is that at one point in this expansion, we're going to have a term where we have 3x squared to the power of n minus r. Remember right here, this is our a, 3x squared is our a, times negative 2 over x to the power of r. Negative 2 over x is our b in this case. And this is going to equal to some coefficient times x to the power of 4. Now, we do not care about the coefficients right here because we do not know this coefficient, so what we're working with is just the x. And an x will not come out of nowhere, so we just can focus on the x's and the exponents that they have. So using just some basic exponent laws, we can write this is x to the power of 2n minus 2r, and then x to the power of negative r is equals to x to the power of 4. And we can ignore the x's as well because we just care about the exponents. And we know that n is equals to 5 because our exponent is 5 over here. N is 5. And create the equation that 10 minus 3r is equal to 4. So 3r is equal to 6 and r is equal to 2. And this step is crucial because once we know the value of r, we are golden and we can go from there. So how we will use this is that we know that x to the power of 4 is going to be the term where we have our 5 and we have our 2, or we can write this down as 5, 2. So now we just have to find this term right here, and this will be our answer. So what the term is going to look like is 5, 2, and then we're going to have 3x squared to the power of n minus r, so 3, 5 minus 2 is 3, times negative 2 over x to the power of r to the power of 2. Now, what is this right here? Well, this right here, just as a side note, I'm going to write it out. It's going to be 5 factorial over 3 factorial times 2 factorial, which is going to be 5 times 4 times 3 factorial over 2 factorial times 3 factorial. We cancel this out. 2 factorial is just 2, so it's going to be 20 over 2. It's going to be 10. 10 times 27 x to the power of 6 times 4 over x squared. And we multiply this, we get 270 times 4 times x to the power of 6 over x to the power of 2. This is going to be equal to 180. You can use a calculator, do it in your head, times x to the power of 6 over x squared. And if you use just some basic exponent laws, you will know that this is x to the power of 6 over x to the power of 2. Just subtract the exponents. It's going to be x to the power of 4. Sorry, that was an ugly 4 at the beginning. So this is going to be our answer. Our term is going to be 1080 times x to the power of 4. So basically the strategy behind this was we set up a little equation that connected our exponents. We only used x's, we ignored the coefficients because we didn't care about them. But we did this to find the r value So then we could know what the combination of the term would be. And once we know the combination of the term, we also know the exponents, and then we just simplify that to get our final answer. So I hope that wasn't too complex, and you can go back and figure out why we did what we did. It might take a little bit of time to get used to, but it's definitely nothing complicated. Now, before I end the video, I just wanted to give you another little case of where we might use the binomial theorem that might not be that explicit. Say we have a quadratic expression right here, and we want to raise it to the power of n. You might realize that the difficulty is that the binomial theorem only works when you have two variables, a plus b, not a plus b plus c. So a little shortcut that we can take that you might have already thought about is we can factorize this. This is the same thing as x plus 6 times x minus 2, all of that to the power of n. Once again, let's use our exponent rules, and we know this is x plus 6 to the power of n times x minus 2 to the power of n. And would you look at that? Now we have something that we can apply the binomial theorem to. This is going to give us two different expressions that we can then multiply. So this was just a little quick note, a bit off topic, but not really, just to show you that there's a lot of uses for this that might be a little bit more implicit, but this is useful. It really saves a lot of time. Imagine figuring out x plus y to the power of 17 by hand. No need to do that. You can simply use this, where you use these combinations, or this right here, to get the coefficient, and simply keep on reducing the power of a while increasing the power of b, so that your power of a is your exponent minus the power of b. So I hope you enjoyed, and keep practicing. And it's really, just let it sink in, do a little bit of practice, make sure you understand it really, do not rely on the formula, but rather make sure you understand why it works and how it works. So have fun, and see you in a bit.